Hello, today we're going to learn how to use height fields in Houdini to create an effect like this. So let's jump into Houdini. Here we have an empty session as usual, and I will press tab and type 0 to create a SOP network as we learned about in the SOP lesson. And let's call this setup. And then dive inside and add a volume. And you learned about volumes in the volume lesson. So type volume and call this height. And then press P to edit the parameters, and for the name set $OS. And this will expand to the name of the node, that is height. And then we want to set the size of this volume to be 1024 by 1024 and 2-dimensional in the XY plane. And then set the size to by size and the div size to 1. So this will create, each square will be 1 meter by 1 meter, and the total terrain will be about 1 kilometer square. Okay, so now we have a height, and we also want a mask. So let's right click this, go to actions and create a reference copy. And this will, if you press P and press on one of these, you can see it has a channel expression, and this expression is referencing the same value in the other node. As you can see, this is called size X, Y, Z. So we don't have to change it in both places. If I change it in the first volume, it will also change here. But we don't want this to be called height. So let's change the name of the node to mask. And right click the name and delete channels. And type here also $OS. And if you middle click, you can see that it will be named mask. And then we want to combine these two volumes into one volume. So press tab and type merge. And the height first and the mask second. And if we now view this and go to the info button, you can see that we have a height and a mask volume in that order. Okay, so next we want to display this. So press tab and type volume visualize, volume visualization, and connect this after the merge and display this. And P to edit the parameters and change the visualization mode to height field. And the density field is the height and the diffuse field is the mask. And the diffuse range goes from 0 to 1, and the preset white to red. And that will display the value 0 as white and the value 1 as red. And let's see what we have. We also want to show this in the ground orientation. So let's add a transform. Tab and transform. And P to edit and change the X rotation to -90 so that it rotates into the ground plane. And let's add tab and null and connect this last and call this out. So this is what we want to display or render later. Okay, so now we have a simple height field. And we want to modify this using a VOP. And you learned about VOPs in my VOP lesson. So let's press tab and type VOP and choose volume VOP. And connect this after the merge. And then go inside and delete everything. And press tab and type snippet. And then P to edit. And here we have a place where we can add VEX code that we learned about in the VEX lesson. And as you remember, you have to export your bindings, so enter a star or asterisk here. Okay, so let's first of all grab the position. So I will type float x equal at px and float y equal at py, and then I will have a float height h equal 0.0 and float m for mask equal 0.0, and then I will assign at height equal the height and at mask equal m. And if we now change the height to say 100, you can see that it goes up. And the same if I change the mask, you can see that it changes the color. Okay, so let's do a quick test here. So I will say that float x times x plus y times y minus 1.0, and then the mask equal, float d equal to d for distance. So the mask is, if distance is less than 0.0, then use a mask of 1, otherwise use a value of 0.0. So this is a shorter way to have a conditional value based on this comparison. So if this comparison is true, then use this value, otherwise use this value. And we still don't see anything because these are really big values, so we need to normalize this by dividing by 512.0, because this is a 1024 by 1024 size height field. Okay, so we can see here that it works. If I assign the mask based on the position, I can get a shape. So next, let's modify this formula. So if I say 2 instead, it will become, let's wait a bit, and instead let's add an arctangent. So a tan 2, that takes the x and y as parameters. And we can mirror this using the absolute of the x. And then we can change the size using the last offset. And this is upside down, so let's take minus y up here. And then we can offset this, so let's say plus 0.5 and a little bit more, so 0.6. So here we have a basic shape. And we also want to do something with the height. So I will say height equal d for distance. So this will set the height to the distance and multiply this by 100. So times 100. So this should be 100 meter high. And because it's upside down, put a minus. Okay. So here we have a starting point, and this is basically the square distance to the contour. So, as you learned in the lessons on, in my lesson on signed distance fields, we can normalize this distance using a SDF volume node. So press tab and type SDF volume or volume SDF and put this after the volume VOP. And P to edit and select only the height in the source group. So now it normalizes the distance. So you have the exact distance to the contour linearly, as you can see here. And you can also set a maximum distance to say 100. Then it will stop when it reaches a distance of 100. So this means that these points are 100 meters from these points in the XY direction. Okay, so now we have a basic 3D shape or a basic height field. So let's add some interesting details to this. So you can add one more volume VOP. So let's press tab and type volume VOP. And as usual, go inside, delete, add a snippet, P to edit, and a star for bindings. And here I will just say, so what I want to do is to change the falloff from linear to a logarithmic falloff. So I will say at height equal log of at height plus 1, because you need to do plus 1 when you work with logarithms. And this is quite small, so let's multiply by 10, say, and divide the height maybe also by 10, and see what we get. Take a little bit more, 50 here. Okay, this is good enough for this lesson. So now we have a round falloff or logarithmic falloff. And next, let's add the noise that you saw here. So for this, we will need noise functions. Let's add one more volume VOP. So press tab and volume VOP. And as usual, go inside, delete all nodes, add a snippet, P to edit, export the bindings, and here we have to sample. We want to do a warp distortion, and that is done by, for this point we will offset the point we will use here. So for example, I may go here and take the height here and put that height here, and that will create a warp effect. So let's use a function called volumesample. So I will say float h for height equal volumesample, and I will sample the at position, or rather I will sample the first input 0 and the first volume 0. The first volume is the height, and I will sample at the position, and then I will say at height equals this sample value, and this should give the same result. So next we want to offset this, so I will say float offset equal O noise, so O for original purling, and then the position to sample, so at P, and then see what we get. Let's add this offset to the position. Okay, and you can see now we get is very small noise. So let's multiply by 50.0, and that's too much. So let's decrease the frequency by dividing the position by 50, and divide by even more, so let's say 100. And next we want to make sure, or rather, let's make this a fractal noise. So you can add the number of octaves, let's say 3 octaves, and then the next number means that if I say 2, then each new octave will have double the frequency, and then the last number is the amplitude, so each octave will be, let's say, 0.5 times the previous octave in amplitude. So this gives a fractal noise, but this is way too much. So let's reduce the frequency. And let's reduce the amount. Let's see. Just a little 20. Let's see 50. Okay, so there's one more thing that is not obvious. We have to make sure that this noise is a vector. So if you type here vector like this, then it will make sure that we get a 3-dimensional noise. And we need to have a last parenthesis. Okay. So, and also we want to make sure that the offset is a vector here as well. And that the y is 0. We don't want to displace in the, that is z is 0. We don't want to displace in the z direction. So let's say offset z equal 0.0. Okay, and next we want to do the same with the mask. So let's just copy this and call this the M, and we will sample the next volume, so input 0 volume 1, and then assign at mask equal M, and this will displace the mask the same amount. And finally, to get rid of this chipping outside, we can multiply by the mask, so this will go to 0. So let's say height equal height times mask. Now these disappear. Okay, so we also want to be able to control the amount of warping. So let's go back to the last VOP and press tab and type parameter. And connect this into the snippet and change the name to amount. And the name to $OS. And you can see if you middle click, this will become amount. And then in this snippet, instead of 50, you can type amount. And then go up and press P on the VOP. Then here we have the amount that we can set to any value. And if we animate this, then we can make this move as you see here. And you can do the same with the ISO max distance to get the height to go up and down, as you see. So this was quite a lot, but I hope it was helpful, and see you next time. Over and out.